not all engineers are good at math, or is that what?
Well, that would actually be the original sentence, not all. It means that there exists. Okay?
No, what you're saying up there is you're saying, the first one, you're just saying there is an engineer that is good at math.
Right, and if you said not all engineers, that means there are some that are good and some that are not.
Right.
Okay? So that's still existential. Okay. All right. Other questions, guys? Okay. So let's knock out this last one. For all students, if you're a computer science major, you must take assembly program. Okay, unless you worm your way out of it because you're lucky. Okay. So let's just go ahead and write that symbolically. Right. So for all x in some domain. Okay. Guys, what domain are we looking at? Students, right, guys? So for all x in students. Okay. And then the rest of it is literally what it says. Okay. If you are a computer science major,
if you or if x is.
we could say if x is a computer science major,
Then x must take a
yeah,
assembly.
then x must suffer, take assembly. Assembly program is horrible.
Do the skill teach?
I didn't mind it, but it's just so tedious. It's so low level. Yeah, it's not that bad. Sometimes it's fun. Sometimes it's just like mowing your lawn. I can do it whenever I wanted. It just sucks to do it. Okay, so I don't know if it's a good analogy or not.
It's not hard, it's just tedious.
Well, sometimes it is difficult, but sometimes it's just tedious. On occasion, it's fun. So it's like being married, I guess. All right. I want to write the negation using symbols. Okay. So symbolically, if I was to write this, okay. So remember, for an existential statement, for a universal conditional, we flip it. We say there exists x in students. Instead of the comma, we say such that. Well, unfortunately, it's not going to be not CS.
X is a CS major that does not have to take.
Yes. Okay. Such that X is still a CS major, but X must not take assembly.
Why wouldn't you be able to replace the is a with domains?
Oh, you can if you want to, but you'd have to define that off to the side, like the predicate. So off to the side, you would have to say like d of x equals x is a CS major, and then you could replace it with c of x. Right. And unfortunately, that's just more writing, and we want less writing, right, if we can. Okay? That's not a note, but you're perfectly fine with that. Okay? And then if I wanted to write that in an English sentence, okay, how could you guys write that in an English sentence? Well, it's almost up there, isn't it, guys? We could just literally just read it off. There are some, there is one, there exists a student. So we would say, there exists
a CS major.
So there exists a student such that the student is a CS major and must not take assembly. I'll get that guys away.
Could it be there exists a student that is a CS major? Can you say that too, or is that just taking something out? Saying there's a student that is a CS major instead of splitting up into
Yeah, sure.
such that.
You could say that, and yeah, that would be fine because it's still not conditional.
Right,
okay?
it means the same thing.
Right, that's fine with me. There's so many different ways to write it.
So because this is an if-then statement, that first part, like the CS major, isn't affected by the not part.
Correct. The
Only the
antecedent.
then.
Only the conclusion is going to be affected by the negation. Okay? And let me go back just to make sure you understand why that is. If you look at the universal conditional statement, I'll check that out, technology. Okay. That's the negation right there. So notice there exists x in the domain such that p of x and not q of x.
I just overread that.
No, that's okay. Or maybe underread it, whatever. So one of the two. All right. But at least you can read. So
Yeah, that's good.
yeah. All right. Other questions, guys, I can answer about this. Not meant to be difficult. Okay? All right. Converse, contrapositive, inverse. Okay? Stuff we already know, right, guys? Just to remind ourselves, okay, because we might have forgotten about this because that was on assignment 1. We might have forgotten what converse, inverse, contrapositive is. So let's just take a step back. Let's say we have the conditional statement, or the universal conditional statement, for all x in domain D, P of x implies Q of x, okay? So that's the form of the universal conditional statement, right? What if I wanted to write the inverse of that universal conditional statement? Okay, well, it would be for all x in domain D.
Not P of x implies not Q of
That's
x?
correct. Inverse is not P of x, implies not Q of x. Good. If I wanted to write the converse of that for all x in domain D, does anybody remember what the converse is?
Q of x implies P of x?
Yep, you just flip them around for the converse. Very good. So it's going to be Q of x implies P of x. Good. And then finally, the contrapositive for all x in domain D,
Negative Q of x implies negative P of x.
not Q of x, implies not P of x. Okay, let me give you guys a minute to copy that down.
Also the quantifier does not change. The
Correct, not for inverse, converse, contrapositive. The quantifier stays. The only time the quantifier changes is when you're taking a negation. Okay? And I want to come back to what I think John and I were discussing before, is that when you take a negation, it has the opposite truth value of the original statement. When you take an inverse or converse, it may still have the same as the original. Okay? The only ones that are logically equivalent, though, remember, are the original statement and the contrapositive. So these might be the same, these might be different. There's no guarantee whatsoever. Okay? All right. So let's just go ahead, okay, write the inverse, converse, and contrapositive of a few of these. In fact, let's just do it for letter B, because I have a feeling if we can do it for letter B, we can probably do it for letter A as well. Okay, save us a little bit of time here. Okay, so for all animals X, if X is a dog, then X has a tail and X has paws. Okay, so let's just go ahead and start with the inverse, just as we can. Okay, so. And I didn't necessarily, I didn't say to write it either in symbols or in a sentence. Let's just write this one in a sentence. Okay.
Will we be asked on the exam, the specific?
Yeah, I will tell you which one, and if I don't tell you which one, you do whatever you want there. Okay. So yeah, because I have to specify obviously. Okay. So the inverse would be for all. What we have animals. So the inverse just takes the negation of each of these, okay? So the negation is,
if x is not a dog, then
if the animal is not a dog, okay, so if the animal is not a dog, good.
Right, just, oh, you're just not, not using X when you're writing.
Right, if I'm writing,
X there.
yeah, if I'm writing something in a sentence, I like to get rid of. But since I didn't specify, you can use the X if you want to. Okay, I didn't say which way to write it. If I were saying an English sentence, no symbols whatsoever, please. All right, so if the animal is not a dog, and then what's the negation of this
then the
last one?
animal does not have tail or has paws.
Okay, and how come it's or and not and?
Because flip, negative flip.
And what law says that?
De Morgan.
De Morgan's law, right guys? Remember, if you take the negation of a compound statement or compound predicate at this point, you have to make sure that you change the and to an or. Okay, otherwise it's not logically correct. Okay, so you would say then the animal does not have a tail. Okay, or the animal does not have paws. That's a sad doggy. No tail, no paws.
The fish.
No, it's not
Fish
a
has
dog.
tail, right?
Bird dog.
It says if it's not a dog.
Oh, good, so it's okay. So it could be like a sloth or something like that, that doesn't have tails or paws. That's okay. So maybe it's a human. Converse, okay? The converse just flips the two statement, the antecedent and the predicate around, okay? So we would say, for all animals, if the animal does not have a tail, or I'm sorry, if the animal has a tail, and the animal has paws, so remember with converse we don't negate anything. Then it is a dog. The animal is a dog. It is a dog. That makes me feel a little better. And then finally, for contrapositive, we would flip them around and then take the negation of this. Okay, let me write it on the other board because I don't want to write it down here. So we would say, for all animals, and this is contra, sorry. So for all animals, if the animal does not have, I need to pick shorter sentences, don't I? If the animal does not have a tail, and maybe less morbid sentences. Tail, or the animal does not have paws, then the animal is not a dog. Okay. Mercifully. Sorry. Okay. Let me give you guys a minute to scratch that down. Okay, not meant to be difficult, right guys? We all know how to do this.
Can you use also the word not, because not goes with nor, right? Isn't it grammatically or?
One more time,
Like instead of or, can you use nor, like grammatically
no,
not?
not means and not.
Okay.
So yeah, unfortunately we can't use that.
Nor, okay.
Okay. So yeah, not's more of like an and statement, case negation. All right, other questions, guys, I can answer about this. Okay, pretty easy, right, guys? Okay. The last thing I want to look at this afternoon is I want to look at multiple quantifiers. Okay. So a multiple quantifier is basically going to be any statement that contains both the for all and there exists. Okay. So these are the two possible forms of one of these multiple quantifiers. Okay. So for all x in domain D, there exists y in domain E. Okay, so D is a domain and E is a domain. Okay, P of xy is going to be a predicate that has two parts. Okay, let me give you guys an example of a predicate that has two parts to it. Okay, and you don't have to copy this down, just to give you guys an idea. P of x comma y equals x greater than y. Okay, that would be a predicate that has two different variables associated with it, okay? And depending upon the values of x and y, that predicate could be true, that predicate could be false. Okay? For those of you guys that have taken Calc 3, this is just a three-dimensional function, right guys? So that's either like a sphere, okay, or it's an elliptic paraboloid, or it's a hyperboloid, whatever it is, okay? We don't care about those in this class, okay? They're fun, and they're pretty, but we don't care about them, okay? So that's what P of xy is, okay? And then the other possible multiple quantifier, there exists x in domain D such that for all y in domain E, P of xy as well. Okay, so, and what I put up here was I put the original statement, and then I want you to take a look at the negation. The negation, to be able to do this, you flip the quantifier, you replace a comma with such that You flip the quantifier again, and you just take the negation of the predicate, okay? So basically, guys, these all follow almost the same format if you want to take a negation, okay? Flip the quantifier, commas go to such that, or such that goes to comma, and then you take the negation of the predicate. Okay, I think they're pretty easy to remember because they all follow the same format. Okay, so let's just go ahead. Let's take a few of these different multiple quantifiers and let's try to write them in a sentence if we can. Okay, this should be fairly easy. Okay, so we have backwards e, x, and r such that upside down a for y and r, x plus y is 0. Okay.
Can we write it just like that?
Unfortunately, because it says to write in a sentence, no. Okay? So let's go ahead and do this, okay? So if I was to write the first part, like right before such that, how would you guys explain that to like maybe a 7 or 8-year-old? There exists a variable x, right? In what domain? In domain R, which is real numbers, right? Very nice. Okay, so there exists some real number or a real number, okay, such that such that what? What's this other part, guys? For all
y,
so for all
y in the domain, all y in the real number,
such that for
real number.
all different real numbers, okay, so for all other real numbers as well, because remember x and y are two different variables, so that such that for all other real numbers,
So there would be two or there to do.
right, to differentiate between x and y, okay, because otherwise you might not know that you're using a different real number,